Great day, students. It's Mr. Sargent here with your recap video for Wednesday. Now, ladies and gentlemen, today's focus was the iReady diagnostic for math. And I know each and every one of you did your best. And no matter how you did, ladies and gentlemen, I am super, super proud of each and every one of you. But I wanted to do something a little bit special. I haven't seen a few of you because we haven't switched. Some of you are at home. We miss you. I wanted to do a little fun review experiment today. So, before we get started with the experiment, we got to get in the right gear, don't we? Much better. Now, ladies and gentlemen, we have been talking about heat energy all week. Now, heat energy is, well, when heat is passed on from one thing to another. We know we can't create energy. We know we can't destroy energy. But we can transfer it from one thing to another. Now, if you look behind me, we have the three ways that heat can be transferred. Right here, we have convection. Now, this is the transfer of heat through fluid, a liquid, or a gas caused by molecular motion. We're going to talk about molecular motion later. Next, we have conduction. Conduction is the transfer of heat or electric current from one substance to another by direct contact. This is heat transfer through touching. And then finally, we have radiation. Now, radiation is energy that is radiated or transmitted in the form of rays or waves or particles. Hopefully, we're going to get a fun experiment to do with that later. All right, but for right now, we're going to focus on convection. Right now, we're going to focus on the heating up of a liquid or water and what it does. It could be even heating up the air. Today's experiment, we use both hot air and hot water, and we're going to test to see if it really does work. Now, before we get through any of this, it's important to know that things are made of molecules. Molecules are tiny little particles that, well, form together to make a, well, state of matter. But what's a state of matter, you may ask? Pause. Ladies and gentlemen, I'm going to pause this video real quick. It appears to me that we may not know what matter is. And what better way to learn about matter than through a vocabulary video? So, ladies and gentlemen, enjoy.
Everything you've ever seen, everything you've ever touched is made of matter. Check it out. Matter is what everything is made of, from the grass on earth to the stars above. Matter is everything that you touch, your notebook, your baseball, even fruit punch. Some matter you can hold in your hand. Can you breathe matter?
Yes, you can.
Matter can exist in three different states. That's solid, liquid, and gas. Okay, a pillow is a solid, so is the door, the walls, the table, the ceiling, the floor. The atoms are packed tight like the holes at dismissal. Moving around quickly is a real issue. Now a liquid could be oil, water, or paint. You can catch it in the cup outside when it rains. The atoms of a liquid are a bit more loose. Liquid takes the shape of the container you choose. Now gas, a state of matter that's hard to see. It fills up balloons. It's the air that you breathe. It's atoms are loose like kids at recess, moving all over the place. They don't rest.
What's matter? Anything that takes up space, made of little tiny atoms to give it shape. When it gets hot or cold, atoms rearrange from solid to liquid to gas.
What's matter? Anything that takes up space, made of little tiny atoms to give it shape. When it gets hot or cold, atoms rearrange from
solid to liquid
to gas.
Here's a fact that might seem strange. Did you know that matter's state can change? Heat gives energy to atoms, so heat makes them speed up, cold makes them slow. Think of a liquid, water in a pot. Turn up the heat, the water gets hot till it boils and evaporates. The water's now with gas, its state has changed. Now put that glass of water in the freezer, it turns into ice. Guess the reason. Low temperature slows the atoms down. The water's now a solid. Atoms don't move around. Now it's ice. but it can change back into a liquid, and that's a fact. Put the ice on the table, watch it melt quickly. The states change again from solid to liquid. Temperature changes, the energy matter has solid, liquid, gas, known as the states of matter. Don't get mad at it. We pull matter out of the hat like go grab it. What's matter? Anything that takes up space, made of little tiny atoms to give it shape. When it gets hot or cold, atoms rearrange from solid to liquid to gas.
What's matter? Anything that takes up space, made of little tiny atoms to give it shape. When it gets hot or cold, atoms rearrange from
solid to liquid
to gas. Okay.
Well, ladies and gentlemen, it comes down to molecules. And let's take a look at the next slide. If something is a solid, the molecules are really, really, really close together. They're so close together that we can't pass through them. Like this duct tape, one of the best science tools ever. We can't pass through this duct tape because all the molecules are so close together, we can't get through it. But if we look at a liquid, they're a little spaced out, aren't they? And if you look here, you can actually find a pathway through the molecules of a liquid. Now a gas, we can definitely go through a gas. That's easy. And once again, we don't even want to try going through plasma. But if you look at where the molecules are, they're so far apart that it would be easy to go through it. Now, so first up, we have our question. Now, our question today is going to be, can we show how to use convection, how convection can change the state of matter, and how molecules can be seen even though we can't see them? My hypothesis is, well, maybe. I don't have all the supplies I need today, but we're gonna make the best of what we can do. And research, well, all week we have been researching, haven't we? So let's find out what we need to do this experiment. So to do this experiment, you just need a few supplies. And I don't have all the supplies here, but I'm kind of hoping it still works. The first thing we're gonna need is liquid. And I have a bottle of, it says vinegar here, but it's actually water. I have 2 containers, all right? I have a metal container and I have a plastic container. I have 2 bottles here. You may only need 1 bottle. And I have one of the best science tools ever, a balloon. So what we're going to do is we're going to test to see if we can heat up air enough to show convection and possibly even a state of matter change. So the first thing that we're going to do is I'm going to pour the cold water into our plastic container. All right. Just like that. Good thing I'm wearing my lab coat because I'm splashing it all over the place. Now, ideally, what I would love to have here, ladies and gentlemen, is ice. We make this water super, super, super cold to show, well, that matter change. But for right now, we're just going to use cold water. And if you hear off to the side, you can hear a coffee pot brewing, can't you? Right now, I am heating up water. Now, what I'm going to do is I am going to put the hot water in this container. So while I'm waiting for that to heat up, we're going to take our bottle, and I'm going to start with a plastic bottle because I think everybody has one of these water bottles somewhere at home. So what you're going to do is you're going to take the water bottle and you're going to take your balloon and place the balloon over the water bottle, okay? You're going to make sure it's airtight because we don't want any air escaping. Now, right now, what do you notice? The balloon's not moving, isn't it? Well, hopefully, when we get the heated water, we're going to see a little change in matter. So now we just wait for the water to heat up. I am now going to pour it into the metal container. And if you take a close look, you can actually see the steam rising. All right, put this back. All right, so now what I'm gonna do is I'm gonna take my bottle and I'm going to put it in the hot water and just watch what happens. Now, I am not squeezing the bottle at all, but if you notice, the water touched the bottle and then it transferred its heat energy. Now, since it's touching, that is conduction, but inside, the air inside the bottle is heating up. And as we know from our weather unit, when air rises, when air heats up, it rises, doesn't it? And now what it's doing is it's going up through the bottle into the balloon and filling the balloon. But what would happen if I put it back in the cold water? Did you see that the balloon deflated? Because once we cooled it down, where does the air go? It sinks again. So let's go ahead and put it back in the hot, see what happens. I'm gonna put it like right here this time. So more of the bottle. Did you notice it? It inflated again, didn't it? This time I put more of the bottle on the hot water. The more area that's touching the heat, the more ways that the heat can transfer from one thing to another. And it inflated the bottle. Now this is a fun activity that you should definitely be careful of because we don't want you to get burned or scorched with the water. But it's actually pretty cool to see how just a little hot water can make that air rise. And a little cold water can make that air sink. So before we go outside, let's talk about radiation. Radiation has traveled through waves and energy waves from the sun. So we're gonna harness the power of the sun to see how we can transfer energy through radiation. Now, we also know sometimes when we have too much radiation or too much heat energy, something could happen. So I want you to see just what happens. All right, ladies and gentlemen, we're all outside. Everybody wave. All right, and to do today's radiation experiment, I'm gonna have Miss Emerson help me out. Say hi, Miss Emerson. Hi. All right, and the sun's pretty bright, isn't it? Well, we're gonna use the sun's radiation to do something. All right, so the first thing that we're gonna do is blow up some balloons. All right, so while my assistants help and put on their safety goggles, we are gonna start today's experiment with 3 balloons. And here we have Steve, Kanye, and Emerson to help us out. All right, so Emerson, what color do you have? Steve?
Green, blue.
And we all made predictions. Which one is gonna absorb the most? The question that I have, ladies and gentlemen, is how are we gonna get the sun's energy, the radiation energy, into into the balloon? How? Say it.
I think the sun is gonna power it.
Okay, you can already see the sun's reflection on the balloon, can't you? But that wouldn't be much fun. It is getting hot, isn't it?
Yeah.
So what we're gonna use, ladies and gentlemen, to help it out, magnifying glass. So let's see.
Let's go. That's cool.
Huh, nothing's happening. Interesting. Let's go to green.
Ooh, I hope mine goes pop.
Let's go to white.
It's gonna pop. It's gonna pop so hard. I'm gonna jump.
Huh.
I'm a man. What?
Wait a minute. The green, the dark green, popped. Why didn't the other 2 pop? What do you think?
Because they're lighter.
Because they're lighter in color. Ladies and gentlemen, darker colors absorb more radiation. Okay? That was amazing. If you saw the darker color balloons popped. they attracted more of the radiation, didn't they? Whereas the white and the light color balloons didn't pop at all. So we can say that the light colors, like my jacket or even my shirt, can reflect radiation energy and heat energy. But our ties, well, since it's dark, it's definitely going to absorb more of that radiation. So ladies and gentlemen, I hope you enjoyed the 2 examples today of all 3 different types of heat transfer. Hopefully you learned a little bit more about molecules. And ladies and gentlemen, most of all, I hope you have a great day, and I cannot wait to see you tomorrow.